Hi everyone, just wanted to take a minute to talk about parallel lines cut by a transversal. And I just want to make sure that we're clear on a couple of the different things that we are going to be dealing with. So, as a reminder, when we are dealing with parallel lines, as in this case, it doesn't directly tell us that A and B are parallel, but usually there'll be some sort of indication like, two arrows, or they would tell us, line A is parallel to line B, or something to that effect. But regardless, we are dealing with parallel lines cut by a transversal. Um, so you'll notice down here we have a couple different areas indicated. So in between the two parallel lines, we have interior. So this area right in here, that's the interior. All right. And then everything that says exterior is up here, everything outside of being between the two lines. Okay. So as you can see from this diagram, you could have the transversal, which is the line that is cutting the two lines at the different points. You could have it going up and to the left, like in this one. It could be going up and to the right. It could be vertical, as long as it intersects the two lines at different points. All right. So there's a couple different types of angles that you can obtain from these lines being cut, but these parallel lines being cut by a transversal. So you'll see right here, down at this one, each point of intersection with the transversal and one of the parallel lines, it makes 4 angles, okay? So we have 1, 2, 3, 4, and then down here 5, 6, 7, 8. So we have 8 angles in total that are made when one transversal cuts through parallel lines, okay? So these 8 angles have different relationships. There's corresponding angles, which, as you can see here in the diagram, they're in roughly the same spot of the where the lines intersect, right? So by that I mean, see, the blue is in the top right out of the 4 angles made by this intersection. The blue here is made in the top right. So think of it that way. They're kind of in the same relative location. So 1 and 5, 2 and 6. They're in the same spot, right? They're both on the top side of the line, and they're both, the one's in the top left, 2 in the top right. So the blue and the blue, the yellow and the yellow, they're both in the bottom right. The green and the green, they're both in the bottom left. The red and the red. And we're told that everything in this box right here is congruent, right? So the blue and the blue are congruent. The yellow and the yellow are congruent. Corresponding angles are congruent, okay? So corresponding angles, these are congruent. And what does that mean? So that meant, so like if we look down here at 1 and 5, which are corresponding angles, we would know that if angle 1, the measure of angle 1 is 15 degrees, then the measure of angle 5 must also be 15 degrees. That's all it's saying, okay? So they are congruent. Corresponding angles are congruent. All right. Now, let me clear everything. All right. The next one that is congruent, alternate exterior angles. Oh, I forgot to mention corresponding angles. When we have corresponding angles, we get 4 sets of corresponding angles, one for essentially each part of the intersection, right? The top right, the bottom right, top left, bottom left, for each of them. And so you get 4 sets. Alternate exterior, as a reminder, the exterior were the ones on the outside. There's only 4 angles on the outside, 1, 2, 7, and 8. So you can only get 2 sets of alternate exterior. And when we say alternate, we're talking about opposite sides of the transversal. Okay, so if my transversal is here like this, we're talking about opposite sides. So this is one side of the transversal, the red side. And then over on the other side, we have, I don't know, the yellow side. So we have 4 angles, 1, 2, 7, and 8. Half are in the red side, the 1 and the 7, and half are on the yellow side, the 2 and the 8. All right? And what we care about in this one is when they're on alternate sides. So if we have one in the red side, the other one has to be in the yellow side. Okay? So if we had 1, the alternate exterior angle for that would be 8. Because we have 1 in the red, 1 in the yellow. And they have to be in the exterior. And then if we had 2, we have 7. All right? And we know that 1 and 8, angle 1, is congruent to angle 8 because it says everything in this box, all the alternate exterior angles are congruent. Okay? And that also means that angle 2 is congruent to angle 7. So all that's saying is if angle 2, again, is, I don't know, 104 D, 140. And the measure of angle 7 is also 140. That's all it's telling us. Okay. And you might be asking yourself, well, why not 1 and 2? Those are a linear pair from what we remember before, and linear pairs are supplementary. So we know that 1 and 2 are not they're not congruent. Also, we don't need the other parallel line for that, right? Why would we bother having 2 parallel lines if I was just going to talk about 1 and 2? So let's erase again, and let's talk at the last one in that category, alternate interior. So again, we're now dealing with the interior, so everything in this green area. So we only have 4 angles again, 3, 4, 5, 6. However, we are still dealing with alternate, so we'll go back to our trusty red and our yellow sides. So you'll see that when we are dealing with this, we again need to have 1 from each side to make it alternate. So we need a 3 and a 6, 4 and a 5. And again, we are told, because these are in this box, alternate interior angles are congruent. All right? So angle 3 is congruent to angle 6. Angle 4 is congruent to angle 5. Okay, and again, we're not going to worry about 3 and 4 because, again, those make a linear pair and we don't need the other line for that. So again, all we're saying is if angle 4 is 65, so is an angle 5. That's all we're saying here. In case you're wondering where all of these things are coming from, like, well, how do we know they're congruent? How do we know things like that? So the reason behind that, a lot of this comes down to, well, once we know that corresponding angles are congruent, that's a postulate. That's something that we just know in geometry. Then from there, right, we have these vertical angles. And because the vertical angles are congruent, so 1 and 4 are congruent. So 1 is corresponding to 5, and then 1 and 4 are congruent. So therefore 4 and 5 are also congruent. Same argument with alternate exterior, right? So if 1 and 5 are congruent, so that would mean 5 and 8 are congruent for vertical angles, so 1 and 8 are congruent. So that's where these are coming from. We're coming from alternate, these other ones over here, the alternate exterior and alternate interior, are coming from vertical angles. That's where we're getting that information. And if you ever come across a problem where you're not given a corresponding angle or an alternate exterior angle or an alternate interior angle, you can always use vertical angles to solve it. All right, now let's look at the last one. So we're now dealing with same side interior. So again, I'm going to look at my different sides. We have the red side. We have the yellow side. But now we're strictly dealing with the interior. So again, we only have 3, 4, 5, and 6. So, right? And again, the color coding matches up. So we need, since they're on the same side of the transversal, we need 3 and 5 or 4 and 6. Because those are the only ones that are on the same side of the transversal. And we're saying they're supplementary. So all that means is that the measure of angle 3 plus the measure of angle 5 equals 180. So if I told you that the measure of angle 5 was 50, I could substitute that in and say the measure of angle 3 plus 50 is 180 minus 50 minus 50. So the measure of angle 3 is equal to 130. Okay? So that's all we're doing on these ones. Same side, if they're ever on the same side and they're both interior, or you could even go further and say if they're both exterior, so 1 and 7, they're going to be supplementary. Similarly with 2 and 8, and then 4 and 6. So the interior ones would be 3 and 5, and if you had same side exterior angles, they would be supplementary as well. You might also see it written as consecutive interior, but same side just means the same thing. Okay, so to recap, corresponding angles, those are the ones in the same location, right? So if I had 2, I have 6. They're in the same location, right? Top right, then 4 and 8, 7 and 3, 1 and 5. Those are congruent. They have the same measure. Alternate exterior angles. Okay, those were the ones outside of in between. So the 1, 2, 7, and 8. And they are on opposite sides. So as I was saying, remember the red and the yellow side. Opposite sides of the transversal, 1 and 8, 2 and 7. And they are also congruent. So they have the same measure. If 2 is 170, 7 is 170. Alternate interior, now we're inside, but we're still dealing with opposite sides of the transversal. So again, the red and the yellow side, and we go in between. So 3 and 6, 4 and 5, again, they are congruent. So if 3 is 120, 6 is 120, 4 is 60, 5 is 60. And then if you ever end up with 2 that are on the same side interior, so, that was really bad, I'm sorry. I held the button too long. So if you ever end up with 2 on the same side interior or consecutive interior, like 3 and 5 or 4 and 6, they add up to 180. So if 3 is 110, 5 is 70. Okay, they add up to 180. Same thing with 1 and 7. So same side exterior. All right. So I hope this helps. We're going to do more practice of this, so don't worry. Please let me know if you have any questions.